Good afternoon, everybody. The topic of my paper is Intelligent Cycle Transfer Object for IoT Data Security. So to give you a quick background, this paper deals with a proprietary data security scheme that is designed by Certainty Incorporation. And what they do is they put uh, data in charge of itself so that it can defend, govern, and track itself. And the way it does that, it adds a intelligence module to the data through authentication, encryption, different kinds of encryption which are not revealed, access control, event audit controls, and context-aware authorization. So after adding this through intelligence module, the data will be kind of a self-protecting data. Uh, so this was created to design the challenge of data privacy, and data can authenticate itself and its users through this uh, protection scheme called ICTO. Data can enforce the policy and take mitigating actions in real time, and even track events, log those events from end to end, and assure its provenance. The main thing is that they haven't revealed what the technology behind the uh, ICTO is, so we're just uh, trying to figure out what's exactly going on, what kind of cryptography they're using, and try to dissect it. So another issue that we're trying to figure out is how well it does in constrained environments. Since it relates to data security, our main concerns also dealt with privacy, data confidentiality, and trust. I'm not going to go in detail into this, but because this is innate to any data security scheme. So in very high level, what the paper does is it takes uh, ordinary data and put it through this something called intelligence module and generates this ICT and UXB. Now there's a lot of steps in between here that I didn't cover, uh, but in high level, what the paper does is it compares this ICTO or the object that is created after protection, which is called UXB, and compares it with traditional blockchain and cryptanalysis. So this blockchain, call it a traditional blockchain because we generally refer to blockchain as a decentralized ledger where there's involvement of cryptocurrency. But traditionally, that is not the case. So traditionally, blockchain is just a continuous growing list of records and which is linked using cryptography. So this is called the blockchain, and if there is a distributed ledger implemented, then there could be proof of work or proof of stake or something used in this blockchain. And if it is of decentralized or distributed nature, there will be multiple nodes. So that was not in the original paper. So this is the part where I changed the code. So instead of comparison with traditional blockchain, I implemented a distributed blockchain with multiple nodes, uh, just using sockets. So this is my main contribution. Now this is the implementation of how figure out how blockchain is implemented, and it's pretty straightforward. Where there will be a server receiving the blocks from the IoT devices continuously and updating to its blockchain. Uh, Now, before I uh, talk about my code, I just wanted to talk the main issues. So, like I said, decentralized ledger wasn't implemented, and single blockchain node was used to measure the performance of overhead of ICTO and blockchain and perform cryptanalysis. This is because of the notion of off-chain storage, where data is not stored in the blockchain, but the hash of the values is stored. And in terms of contributions, what I did is I designed a decentralized blockchain using cryptographic hashing and established a persistent socket connection with multiple nodes operating on a as-needed basis. So I also engineered a way to embed any files into the blockchain architecture and use the gossip protocol just using socket connection. And socket programming, I think we already did it in our lecture as well. So and it's fully automated. And this was the hardest part of the uh, process is to make it automated. And I'll show you in the code how I achieved that. So the basic steps of how the nodes are get updated is shown here, and I also added it in my README file. So basically, any node can create the blockchain or start the blockchain, creating a Genesis block, and then it will have a submit a proof of work to find the proper nonce value. After that, UDP communication is used to send information about if any blocks needs transferring. So I use UDP in this case because it does not require predefined connection to be established. That's why I chose UDP. And after we make sure that some blocks are needed to be updated in some nodes, then I use socket communication to transfer the blocks to every node. And I just repeat this process. All right, now I'm going to explain about my code in a bit. And it's the same for both of them. So I just kept it as this is the node A part, this is the node B part. So I just need to change the IP address and the port address and the path for each of the nodes. Uh, so starting with the server, we have already done this in the class. We have already established a socket communication between one node and another node using socket communication. So this is the same code that we used in the class, but the difference is that uh, I will take a variable, the port size, the port address should be the port address that you want your server to start on, and this is the IP of my server. So this is basically the IP address of the port A. And I've also introduced this uh, private key and public key, which I'm gonna demonstrate later as well. So this is the private key of my node. So I'm using my private key to decrypt the file that is sent by other nodes. So other nodes will encrypt using my public key, and then I'm using my private key to decrypt it. So I'm basically using loading my private key and then starting this socket and listening to the connection by binding the socket with this address. So basically this server IP and server port. And then I'm listening for the message and I'm decrypting it using this private key and I'm writing it to a new file called this index.txt. So this index is basically passed through the function which I've written in uh, which I called from this gossip protocol. So I'm going to talk about later. And then I finally close the server. So this is the server. Now, if we want to talk about client, so what happens in the client is basically I'm writing the same code as server code, but instead of opening the server, I'm listening to the server. So I'm using the public key for server loading my public key so that I can encrypt the data. And same thing here as well. I'm using the IP. You can pass the IP through the Gauss protocol as well, but I just wrote it here so it would be easier to understand. So this is the IP of the server, right? Because in the IP of the server for the client. And then I'm binding the address and so on and so on. And this thing is just encrypting the message before passing it through the passing to the server. So encrypting it and passing. And once all the data is passed, closing the connection. So for this demonstration, I've used the same computer, same machine. That's why the IP address is the same, but I used it on different port. You can try it on different PC as long as you're on the same local area network. I tried it in my Linux and Mac and it worked, but I couldn't demonstrate it because I have to record it on two different devices. So that's why I just use different ports for now. But since you're on local area network, it will basically be the same. You just have to change this IP address. It should be something like port or something. Port address could be the same. Okay, after this, I'm going to talk about this gossip protocol. So in this gossip protocol is the main part of my code. So whenever blockchain, so if I go back to this presentation, uh, so the way the different block so the way this different node communicates is something called gossip protocol. So every node has to update some block that it created to every other nodes in the system, right? So this can create a lot of problem because what if the node B and node C will creates a new block at the same time, and if they are passing that block to different nodes, what will happen then, and so on. Those are some extreme problems that I haven't dealt with, but in this uh, code, what I've done is once the some node creates a block, it will uh, continuously try to update it to the other nodes. So this is the basic code for callers, but uh, I created a class for gossip protocol. I just printed out my IP endpoint just to see if everything's working fine. So I've written different functions that perform different tasks. So this will find the latest block in my blockchain. I'm going to talk about blockchain in a bit, but it finds the latest block by looking at the file that is sent through the client and through this by the client. So this ask question function basically asks if you want to continue or if you want to update your blockchain. So I'm gonna show this in a bit. This transmit message, this to transmit message functions is basically for transmitting the message from. So it's basically calling the UDP, servicing a UDP, creating a UDP communication. So UDP communication, as you know, uh, is very easy to set up, and it doesn't uh, require any kind of prior communication. So what I did is I used UDP to establish the communication so that it will know if there is a particular node requirement. Only if the block isn't in the node, then I will transfer the block, right? So there is no need to establish a proper uh, TCP communication uh, because TCP communication is handshake and stuff. So instead of just doing that, I will just create a UDP communication and I just forward that, hey, I don't have this block, or the node will say that I am at this block. I need, if there are any other new blocks, send me that blocks through UDP. So this is what this send to will do, and it will send the message to those address, and this is the port number. So that's the function of this transmit message. And this message just receives the message from the client. So that's why I have to run this server. Now I'm passing this index I, which is basically the value of the name of the file. So as you can see in this server that by this index is basically the same index. Uh, all right. So then there's one set step of just printing out my block number in my node and the other node, and then if the new node is not present, or I mean the new block is not present, then it will ask the other node to send that block. Otherwise, if I am this node is as the current block, then it will forward the current block by uh, being the client. So if you're a client, you're basically sending the block. If you're a server, you're basically receiving the data. All right. Now this final uh, function is basically there to handle the input of messages, and it also allows for the performing these operations simultaneously. So it's starting a thread. So that's my gossip protocol, and this node is basically the only file that I need to run. So it just defines the hostname and the other nodes and just calls the gossip node from the gossip file. All right, so this blockchain is basically uh, basically consists of this hash generator. So generate the hash of a particular file, or generate the hash of a particular text or number or anything. So this will generate for the text, this will generate for the file. This is the path where my blockchain exists. So this is the difficulty level. This is basically the number of zeros that you want, or the in the hash. Uh, this nonce is the value that is just used to generate the hash. Now, the only thing that you guys might find difficult understanding could be this. This is just the just to make sure that my hash starts with a particular number of zeros. Same here as well, the proof of work. And this is the function to add the block. So basically, if there is block in my file system, it will just keep on adding that block depending upon if it already has that or not. And I'm just checking this for my sanity, if the current block has a previous block is equal to has a current block or not, and then creating an instance of blockchain, and then I'm using this values 1, 2, 3, 4 in order to get the decision from the user. So if user wants to say the uh, just to print out the what is in the blockchain, they'll press 1 and he'll just see all this index data, timestamp, and so on. So if I want to update the block, I'll just press 2 and the latest blocks will get updated. So this basically means that if a new block has been added from other node, then it will add it to this blockchain. So you can add a new file by pressing 3. So you'll just add a new file. You just need to write the name of the file, and for everything else, it will exit. So the same code is for this. For other nodes as well. The only thing that you need to change is this IP address and this port address. Okay. All right. So so this is my node A and this is my node B. I have the public key for node B or node A because I need to encrypt it with the public key and decrypt it with private key. Okay. So let me run the node A here and node B here. So there is no blocks on the blockchain. So if I run the blockchain on any node, it will create the first node, which is basically the Genesis node. So if I say it just is the data is the Gen hash, the current hash starts with 3 zeros and so on. I want to update this block on the node B. So I'll just update it from node B by sending the UDP message, which will start the server on node A, uh, start the server on node B, sorry, and then the node A, which will be the client, will send the data to node B. So as you can see, if I run the blockchain code on node B and display the block, it would basically be the same. All right, now let's create a block on node B instead of node A. So if I just press 3 and add one of the files, I'll just create a new block. So I can see this block, it has the previous hash is same as this hash, and the current hash is the new hash. Now I want to update this block in the node A. So I'll just press 1 on the node A. So it will send the UDP message to node B, and it will start the server on node A, and the node B will send the data. So basically to the txt, or the data which is encrypted and encrypted by node B will be decrypted in node A and will be seen in plain text to the txt. Now if I go back to my blockchain on node A and see my update my blockchain and see it, as you can see, it has the same hash. So in this way, I just updated the blockchain and added the blockchain in same blocks in two different versions of blockchain on two different nodes.
So the lessons that I learned from this project was mainly related to the sockets, understanding how TCP and UDP communication can be established using sockets, and management of blockchain hashing, as well as encryption and decryption with the RSA. I also learned about the consensus algorithm, especially the proof of work. So the various problems that I faced in this project was mainly related to the setup of the socket communication and the timing issues that I faced with it. Uh, because of the dynamic network changes, adding, removing nodes, there was a lot of issues with that, and automating it was also the biggest challenge of this project. Thank you.